In this video, we're going to look at linear regression using the TI-84 graphing calculator. First thing that you want to do if you're going to do a linear regression, you're going to go to Stat and Edit and enter your data. I've already entered data into L1 and L2. I always suggest that you use L1 for X and L2 for Y. If you've got more data, you want to use more lists in the calculator. There are ways that you can move the data around, store it under other names. What I find for the graphing calculator is that a lot of the defaults are set where our X value is in L1 and our Y values are in L2. So for this video, this is the way I'm going to leave things. The data that I'm going to use comes from some sample data that I've looked at from a course that I teach, where L1 represents students' mid-year exam scores and L2 represents their final exam scores. There's another video that you'll find that I've made showing linear regression using Minitab. What I like about Minitab is it's just so much more descriptive. You can see what you're working with. You can name the data. Here, there's a lot of remembering that you're going to have to do and interpreting you're going to have to do from the graphing calculator. But it will do linear regression. Minitab just does it much more attractively, simply. In any case, now my data is in L1 and L2. Make sure that you enter it correctly. The other thing you want to make sure, and I'm going to go up here to get to the bottom of my list, is you want to make sure that you have the same amount of data in each list. One place where students run into confusion is they might miss a piece of data. For example, they miss a piece of data here, and they have different dimensions. They have 33 pieces of data in L1, and they have 32 pieces of data in L2, and then their calculator is going to scream at them, and there's a dim mismatch, which means that there's a mismatch in the dimensions. If I remember correctly, that number was a 75, so we'll put that back. So first of all, in the graphing calculator, I can go to second stat plot, select plot 1, turn it on, and I'm going to pick the scatter plot. Notice the default, X list is in L1, Y list is in L2, and then you're going to pick a mark. Do you want each point to be represented on your scatter plot using a box, a plus, or one of the two dots? Okay. I have said in the past, I find the dots are a little bit too small. I find that the boxes are a little bit too big. For me, I find the pluses just right, but you can do whatever you want. What you want to do is, before you run your scatter plot here, go to y equals and just make sure that this is clear, okay? Because that's going to cause issues with you when you go to do your scatter plot and do some work. Now, I don't remember what that equation was that I had there, and it doesn't really matter. But let's suppose that the equation that I had there was something important, right? Like 2x plus 3, and I just can't write it down. Notice that when I entered the 2x plus 3, this equation became darkened. This equal sign became darkened, okay? I can go back here and press enter, and notice now that it's not darkened, which means the equation is still there, but the calculator won't try to graph it, okay? So either way you want to handle this, you do want to clear, you want to make sure that your calculator is not going to try to graph something else. Zoom. Option number 9 says zoom stat. You want to select option number 9, and the calculator sets your window so that you get to see all of the data in the graphing calculator. Okay, so there's my scatter plot. It does appear that there is an upward trend. Students who did higher on the mid-year did higher on the final. Okay, now if I'm in Minitab and I do this graph, it's going to show me words at the bottom that say mid-year exam and words on the left that say final exam. The graphing calculator does not have that sophisticated of a display screen. So now if I go back to stat, calculate linear regression, I'm going to choose option number 8 since we're in statistics and we like to write initial value plus rate of change, a plus bx, as opposed to in an algebra class, ax plus b. It really doesn't matter a lot, but for consistency, I'm going to select number 8, choose number 8. My X list, L1. My Y list is L2. Frequency list, every single data point is counting exactly once, so I'm going to leave that blank. Store regression equation, I call it RegEQ. To store the regression equation, you can select alpha F4. This menu pops up, and you can decide in which place do you want to store the regression equation. I'm going to select Y1. okay? And then I'm going to select calculate. And when I do this, the calculator will give me my regression equation. Notice A, 18.19, B is 0.674 with an R squared of 0.574 and an R of 0.757. Okay, so that information is there. Now, if I press Y equals, remember I had made this blank, my regression equation was pasted into Y1. So if I go back to if suppose the equation I had in my Y1 was important and I wanted to save it in Y1, I probably would have stored my regression equation into Y2 or Y3. Okay, so just be careful that there's nothing that you're going to erase by putting it there. Now notice when I press graph, not only do I have the scatter plot, but the calculator is also putting the regression equation onto my plot with me. Okay, now that's linear regression using the graphing calculator. I can say, what if, second calculate, what if a student received a score of 80 on the mid-year? What would I predict they're going to get on a final? And I'm looking at a 72.12. If X is 80, I would predict Y to be 72.12, and that's my Y hat value. So the calculator will do that, and there are some limitations there. So if all you want to know is how do I do a linear regression using the graphing calculator, you're good. To go beyond this and say, well, suppose we're going to do a hypothesis test to determine whether the relationship is significant enough to determine there actually is a statistically significant relationship. To test the regression, stat, tests, and I want to go all the way to the bottom of the list. Now I can go to the bottom of the list by cursoring all the way down, or I could have gone up. I'll show you that in a moment. But I want to select option F, the LinReg t-test. Okay. The next thing I'm going to do is I'm going to select option G, and I'll show you how to get there in a moment. I want option F, the LinReg t-test, linear regression t-test. If I select this, again, my X list is in L1, my Y list is in L2, frequency is 1 because each piece of data counts once. I'm testing to see if beta or rho, I'm going to say, are they different from 0? And then my regression equation is in Y1, and I'm going to select calculate. So notice the calculator, Y equals A plus BX. My null hypothesis is that beta and rho both equal 0. So my alternate is that they do not equal 0. I have a t-value of 6.460. A p-value, remember it's not 3.33, it's times 10 to the negative 7th. So my p-value is 0.000. Now notice I have an A value of 18.2 and a B value of 0.674. So when I run the t-test, the calculator will also give me the regression equation. So I don't need to go to stat calc linear regression option 8 if I'm going to also do the test. The calculator will do the test right here. Okay. We have an R squared, and R values are also repeated. So since my p-value is 0.000, we can conclude with 99% confidence that yes, in fact, there does appear to be a relationship between the X and the Y.